So we are pleased to have our own Rod Brown be the speaker. And is this your third time speaking, I think?
I think so.
Third time speaking, so you've heard a little bit about Rod, in addition to what you already know, that he's our Secretary Treasurer and our telescope specialist. But did you know that he is on the board of the Bear Yuba Trust Fund, Land Trust, is the chair of the Nevada City Planning Commission, and is the program development manager of the National Library Telescope Project. So in addition to all the astronomy duties he has, he's done a lot of civic work, and we are very happy for him to be speaking tonight. His topic is, "It Ain't That Cold, a Dozen Winter Observing Highlights." So let's welcome Rod.
All right, thanks, Greg. So, it ain't that cold outside. It's really not that cold outside. This is California, you know, we're below the snow line, at least here we are. And so my whole point of this presentation is to say why you should actually go outside this time of year. There's a lot of good reasons, and I've listed some of them up here. One of the great reasons is that the air can be especially transparent. So transparency is the clarity of the air. This time of year, there's typically no smoke, thank goodness, a little dust in the air, and sometimes we have clouds, sometimes not, but the nights we don't, it's the transparency can be really good. And I know Dave and I have been going out to Washington Road sometimes in January and had some really spectacularly clear nights. Another great reason is that there are fewer people outside. Everybody's inside where it's warm, so you can go outside and have the darkness to yourselves. And the fact that fewer people are out tends to keep it a little bit darker. One thing that I didn't put up here too is that with the weather patterns that we get around here, one thing that I've seen is that sometimes when there is fog down in the Sacramento Valley, that helps block out some of that light pollution from there too. So that's another great benefit, is that it can be a little bit darker this time of year too. And I don't know, at least for me, it doesn't work well with astronomy, but I'm naturally a morning person. So I tend to go to bed early, except when I'm observing. Well, the great thing about this time of year is that you can go out, you can get started very early, sometimes like 6:30, be observing, wrap up, and you can observe for a couple hours and get home before 10 and get back to bed. So more great reasons to go out. All right, next slide, Greg.
Question?
Oh, question I can't see, so say something. Yeah.
On that last slide, maybe Dave, what is that bright object below the belt of Orion?
Yeah, we're going to get to that. That is the Orion. That is the Orion Nebula.
Is that process to bring out the nebula?
Dave, you want to talk about your picture?
It wasn't a process to bring out the nebula. Actually, the time exposure simply just made it look fairly bright.
Okay, cool.
So you notice a lot of our photos are our own photos.
Yeah, this one was last month. This is a new photo. So Dave took this out at Washington Road. That's the view to the east from that site where we typically set up. All right, next slide. So one of the reasons that it can be not cold out is that you're prepared. If you're prepared, you don't have to be cold. As most things in the winter, layers are always a great idea. If you are setting up, you'll tend to be a little bit warmer. You'll stop moving and start observing. You'll get a little bit colder, so you'll put on different layers. Later you're packing up, you'll get warm again. You'll put on more layers or take off layers. I find that ski wear works well, a down jacket, and I've got these old ski pants that I take out that have a zip-in liner. They work well. Something that I've started using recently is, don't quite look like the model there, but these insulated coveralls. The great thing about that is that they're all one piece, so you don't have air getting in the middle, so fewer air gaps. That tends to keep you warm too. Hats are important. I wear 2 of them because I have no hair. Also, I find I tend to lose heat around the neck, so a scarf or like a hood or something that keeps that heat from going out will keep you warm too. Warm socks and boots, of course, and then some things that I find are typically more optional. Generally observing around here, I don't find that I have to use gloves very often. I keep them. Occasionally I put them on, but most of the time I don't need them. You can also get these USB rechargeable hand warmers. You might be used to the old chemical hand warmers. Those still work just fine, but those are one use. Well, with these USB rechargeable ones, you plug them in, you charge them up, use them for a while, and once they die, you just charge them up again. So they are pretty much, I wouldn't say infinitely reusable. Batteries wear out eventually. But anyway, I have some of those. I haven't found that I've needed to use them. Similarly, warm drinks. Some people like to have warm drinks when they're out there too. All right, next slide. It's important if you are going to observe in the winter to check the forecast. I listed up there some of the good observing forecasts that are there specifically for astronomers. They will tell you different things like the transparency, the seeing, and the dew forecast typically as well, in addition to things like sunset times, moonrise times, and all of that. Of course, in the winter, you've always got that chance of clouds and precipitation, so you want to check the forecast for that. Another important thing is that although transparency can be better in the winter than in the summer, oftentimes the seeing is worse. That's because with these different temperatures, you have a lot of churning of the air masses out there, and that causes that sort of bubbly action that you see, the unsteadiness that you see when you're looking at things. So it helps to have a forecast to check that out, to plan to go out on a good night for that. Dew is also an important consideration in the winter too. If you look at that SCT there in that top picture, this has happened to me many times. I'll set up the telescope, I'll forget to put on my dew shield or dew heater. All of a sudden it's like, I can't see anything. It's like, dew set up again. So there's a lot of different solutions out there for that. The cheapest and the easiest is the dew shield. That's like the one that you see there. You can even make your own. It's just take a piece of stiff cardboard and some duct tape and wrap it around and make it like 1.5 or 2 times the size of the diameter of your scope, and that will help keep that off. I've got some dew heaters that I use too that help. You can also get these, literally it's like a 12 volt, it looks like a little mini hair dryer. You can plug it into the cigarette lighter or the battery pack that you carry around. You can blow that onto that front glass of your SCT in this case, and that will help evaporate that dew. One other reason to look at the forecast, but also just to go out and check the site is, we tend to be around the snow line here. We did have some snow earlier this year, and when I first went up to the Washington site in January, I was a little concerned that it might be under snow because I've been driving back and forth to Sugar Bowl to go snowboarding, and that turnoff to Washington Road definitely has some snow. So one day on my way back from Sugar Bowl, I just dropped down the road and checked it out. It turns out that site is just enough lower altitude that there was no snow there, so it was good to go. Anyway, if you are going to observe at a place near the snow line, definitely check it out before it gets dark. All right, next slide. Okay, so that's all the reasons why you should go out, how to be prepared, what to look for. But now let's talk about what you can see. So one of the great things, and Greg sort of showed a little bit of this in some of the pictures that he had in his presentation, is that there are different constellations in view this time of year than there are at other times of the year. There are also some great fine open clusters. I think those are some of the things that I've been finding myself looking at a lot recently. And as always, there's double stars. There's pretty much great double stars out any time of year. There are many galaxies. One of the things about this time of the year is that the center of the Milky Way is really outside of the main field of view here. So we're seeing other parts of the sky, and because of that, we don't have that bright Milky Way right in the way. You can see more galaxies in parts of the sky too. Some of the things you can look at are what we talked about already. The biggest and easiest nebula to see out there, the Orion Nebula, the Great Orion Nebula. I think it really is great. And one of the things I got to check out, what I call the most iconically challenging nebula, at least to see visually. There's all sorts of things to see, and I'm going to cover things you can see with the naked eye, with binoculars, and with telescopes. And I know I've talked about this before in some of the other presentations I've done that, all of these things are good. You really should use all of these things. If you don't have a telescope, don't worry about it. That's not a reason not to go out and observe. You should be looking at things with your eyes. There's great things to appreciate just with your eyes, and things that are better with binoculars and smaller telescopes too. Got another. I should also mention that the moon is always up there, except during the new moon. Dave's got another great picture here that he took last month as well. All right, next slide. So winter constellations. What you see there, that polygon, I'm going to call it. Some people call it the winter triangle. Some people call it the winter hexagon. Some people call it the winter circle. It's all depends on how many stars you want to count in that loop. But that is essentially a loop of some of the brightest stars in the winter sky. You've got Aldebaran up there in Taurus. You've got Rigel down there in Orion. You've got Sirius down there in Canis Major, the big dog. You've got Procyon down there in the little dog. You've got Pollux and Castor there in Gemini, and Capella up there in Auriga. And you can probably even add or subtract a couple different stars in there too to make that polygon. But that's a great sort of way to have a visual mnemonic, I guess, for the winter sky. Other constellations that are here too are Cancer. I'll talk about Cancer. You can see Leo down there towards the bottom, which you can see identified with the sickle of Leo's head. And I'm also going to talk about a few things that are in the northern sky. So they're circumpolar that you can see any time of year, but which are also pretty good this time of year as well. Let's see, which ones didn't I call it? Monoceros is shown in there. That's the essentially a one-horned rhinoceros, not a unicorn as some people tend to think of it. That one's a little more challenging to see. I know I've tried to look at it some nights out there. It's some pretty faint stars. If you're in a darker spot, you'll be able to see that, but note that that's not going to be as obvious as some of the other constellations here. One of the ones that I don't know why, maybe it's just because of the cute ears, is Lepus, the hare, the bunny rabbit that you see right there at the feet of Orion. I don't know, that one has started jumping out in the sky to me for some reason. Yeah, I think those are the main ones that I'll cover. You can see links over there as well, but I think that covers it pretty well. Let's go on to the next slide. All right, now we'll start getting into some of the things to look at. I'm going to start with open clusters, and I'm going to go from some of the bigger ones, the ones that are easiest to see with the naked eye and binoculars, down to some of the smaller ones. Some of these, if you're an experienced observer, I know you're going to be familiar with these. I'm bringing them up for people who are at different levels of observing, but also because, I don't know, some of these are just beautiful objects, and even though they're well known, I don't know, you take a look at them all the time. I think the Hyades are one of these. This is one of the most obvious open clusters in the sky. It's also the nearest open cluster to the Earth. So it looks very large currently because of that. There's a lot of different stars up there. There's different colors. There's double stars as well. And it's very easily visible to the naked eye. And it's a great one to look at with binoculars as well. Let's see, I did want to cover a couple things in terms of just the mythology here. In Greek mythology, the Hyades were the 5 daughters of Atlas and the half-sisters of the Pleiades, which we're going to talk about here soon. After the death of their brother Hyas, the weeping sisters were transformed into a cluster of stars that was afterward associated with rain. As a naked eye object, the Hyades cluster has been known since prehistoric times. It is mentioned by numerous classical authors from Homer to Ovid. In Book 18 of the Iliad, the stars of the Hyades appear along with the Pleiades, Ursa Major, and Orion, and the shield that the god Hephaestus made for Achilles. In England, the cluster was known as the April Rainers from an association with April showers, as recorded in the folk song Green Grow the Rushes O. That's another great thing about a lot of these more easily visible clusters and object in the sky. There's some great history associated with them too. Let's go on to the next slide. So how do you find it? It's pretty easy. This is pretty much right at the head or the horns of the bull of Taurus. If you look and see Aldebaran, Aldebaran's actually not part of the Hyades. but it's in the vicinity of them. It's an optical alignment there, but you can find it pretty easily by looking up at the bowl there too. All right, on to the next one. The Beehive cluster, M44. This is another one of the open clusters that's nearest to the Earth. You can see the sizes there and the magnitude. This is another one that's pretty much beautiful with all sorts of different with different observing tools to look at. On this one, nearly 2,000 years ago, the astronomer Ptolemy described M44 as the nebulous mass in the breast of Cancer. It was Galileo who first telescopically observed the Praesepe. This is another word for this cluster, which means manger, bed, or cot in Latin. He did this and was able to resolve 40 of the stars there. Let's go on to the next slide. So how do you find this? It's in Cancer, and you can see it's essentially northwest of that junction there of the stars there. It's another one that's pretty hard to miss if you look in that vicinity. All right, next slide. The Pleiades. I think everyone is familiar with the Pleiades, but they are some of the most beautiful objects up there. And I think this is one that I had a friend who was up in Alaska. He normally lives in the Bay Area, so he doesn't have a good view of the sky. But he was up in Alaska and he sent me this picture. He's like, "What is this thing up in the sky?" And it was the Pleiades. Yeah, he could just see it beautifully, much more beautifully than you could ever see it from the Bay Area. And it really jumped out at him. So it's another one that's a great whenever you have a chance to look at it. The Pleiades are an open cluster, as you see here, and there's some faint nebulosity around it. And it's pretty clear when you look at the Pleiades, especially through a telescope, you can see that glowing gas in the area. This is another one. I'm not going to go into all the history here. I touched a little bit on it there in the Greek mythology, but there's a lot of different mythology and different stories in different cultures surrounding the Pleiades. Actually, go ahead and click again, Greg. One of the things is that it is called Subaru in Japanese, and that logo represents the Pleiades. If you didn't know that, you can sort of see that there now that you look at it. Yeah. Yeah, well, it depends on maybe different cultures count different ones. And there's actually more than 7 in there too, right? So it's all what you choose to count. And maybe the graphic designer who made the logo deleted one for aesthetic purposes. All right, let's go on to the next slide. Again, I think it's pretty hard to miss the Pleiades, but here's how you can find them sort of, looking off from Taurus there to get to the Pleiades. And they tend to, if you see the Hyades and look up from there, you tend to see the Pleiades as well. All right, next slide. Now we're going to start getting into some of the smaller clusters, some that you might be able to just make out as a smudge in this case with the naked eye, but you're really going to need some magnifying power to see some of the details in them. This is one of them, M41. I think it's a beautiful open cluster. You've got some of the details there about it and its distance. You can see it's a little bit farther than some of the other ones that we've talked about, hence the size of it. I realized I forgot to mention that open clusters are groups of stars that were essentially formed around the same time in the same stellar nursery. So that's why you see them together, and they tend to be typically around the same brightness and such too. M41 was discovered by Giovanni Battista Badierna sometime before 1654, although it was probably known to Aristotle as far back as 325 BC. If true, this would make it the faintest object recorded in classical antiquity, but caution prevails as Aristotle may have described a nearby part of the Milky Way instead. So some more great history about that. All right, next slide. And so how do you find this? So go to the big dog and the big bright dog star in the sky, Sirius, and go south of that, and you can get to M41 pretty easily. Okay, moving on to the next one. Yes, M35 and NGC 2158 open clusters. Actually, I sort of looked at, I had seen M35 before, but I had browsed by NGC 2158. And last month when I was out observing, I had a list of open questions like, oh, I don't have this one checked off. And I went and looked at it. I was like, oh, it's right next to M35. It's literally like right there in the same field of view. Um, so I think it's sort of cool that you get a 2-for-1 in this case. And it's pretty neat to see because you can see some differences there too in terms of, how they look. M35 is looking a little bluer and a little less dense, and 2158 is looking a little more yellow and more dense. They are at different distances, so you can see there's a pretty big difference in magnitudes there. 2158 is much dimmer. You can see M35 as a smudge if you're in really good dark skies and have some good conditions, but really you need a telescope or binoculars to look at that. And to see 2158, you really do need a small telescope or larger. I think these are both great open clusters. Let's see, looking at the history on these, curiously, despite being a naked eye object, M35 was not discovered until 1745 or 46 by Philippe Lois de Chazeau, and then independently rediscovered, quote unquote, by John Bevis. I guess you needed an Englishman for some reason, in 1750, just a few years later. Next slide to show where it is. So look for the twins and look at the foot of Castor and go northwest. Remember, in the sky, west and east are reversed if you're looking at a star chart. So go northwest of that foot and you will find M35. Okay, next one. I wanted to put at least one double star in here. I think I might have even talked about Almach before, but it is a beautiful star, a beautiful double star. And it's actually not a double star, even with the telescope you're only going to see a double, there's actually 4 different components to it that can be determined through different measuring techniques. But the different colors here, are make it one of those beautiful things to look at in the winter as well, if you're looking for something other than the typical doubles that we see in the summer. This you do need a small telescope to split it with, but again, a small telescope is fine. You will be able to split that double with those. Next slide, please. And this is part of Andromeda. So if you just go out and look at the end of Andromeda there, you will find Almar. All right, moving on. Next one. Again, I think most people are familiar with this, but one of the reasons I bring this up is that this is an object that is great to look at with anything, whether it's your eyes, whether it's binoculars, whether it's a small telescope, whether it's a large telescope, whether it's a camera and taking pictures like Greg did for this. It's just a great object to look at. This, to give a little background on the Andromeda Galaxy, it's the largest member of the local group of galaxies, and the local group is about 50 galaxies that are essentially gravitationally bound to each other. And we are in Milky Way, the other biggest one of the galaxies there too. It is the most distant object easily visible by the naked eye, which is pretty cool if you think about it. 2.54 million light years from Earth. So when you see that, remember that light is 2.54 million years old. Another thing too is that it's got 2 neighbors, 2 elliptical galaxies that you can see there in Greg's photo, M32 and M110. As I mentioned, this is easily visible in all sorts of observing devices. And as you might imagine, there's a lot of history associated with it too. The Andromeda Galaxy was first recorded over 1,000 years ago by Isfahan-based Persian astronomer Abd al-Rahman al-Sufi. In 964 AD, he described it as the little cloud in his Book of Fixed Stars. The object was almost certainly known for a number of years before this date to other Persian astronomers. The first person to telescopically observe and describe M31 was German astronomer Simon Marius on December 15th, 1612. Unaware of both al-Sufi's and Marius's discovery, Giovanni Bautista Badierna independently rediscovered the object sometime before 1654. So you can see there's a lot of history with this object as well. Next slide. This is another one that's great to know how to find. It's fun to be able to show people this if you're out some night and be like, hey, want to see another galaxy? And you can use these clues to find it. There's really two great ways. One is to use one of the triangles of Cassiopeia and use that as a pointer to go down to the Andromeda Galaxy. Another is to use those two stars in the two branches of Andromeda there and draw a line and then extend out again the same distance to go up to the Andromeda Galaxy. Again, those are probably the most famous ways to find an object in the sky, and it's a fun thing to be able to show people. All right, next one. Now we're going to start to get into a little fainter. So I mentioned Andromeda, I mentioned the Milky Way being another big one in our local group. The Triangulum Galaxy is also in the local group too. Occasionally you hear this called as a pinwheel. Multiple galaxies get labeled the pinwheel galaxy, but this one I think is best identified as the Triangulum Galaxy, given that it is part of the constellation Triangulum. It is relatively large, but and you might think it's observable with that magnitude, but remember, that's the integrated magnitude. That's if all the photons were lumped together into one point, essentially, but they're spread out. So it's got a low surface brightness, and it can be challenging to see. You can see it at a dark site. I've actually been at a dark site and been able to pick it out of the sky before, just as a little faint smudge. But with binoculars, you'll be able to find it pretty easily as a misty patch. If you get into telescopes, the larger the better. You will be able to pick out more and more details of the spiral arms. M33 was probably discovered by that same Italian astronomer Giovanni Battista Badierna before 1654. He listed it in his work regarding cometary orbits and admirable objects of the sky. And then Charles Messier independently rediscovered it. It's sort of like how these guys take credit for things that were done by people before them. But he independently rediscovered it in 1764. Next slide. So how do you find that? So we talked before about tracing up to go to the Andromeda Galaxy. This finder chart doesn't have the line shown in the other branch of Andromeda there, but you can see it with the mu there. But if you go in the other direction, you can trace down to Triangulum. The other way to look at it is really just look off the tip of the Triangulum constellation. Triangulum's not a really bright constellation, but if you're in a darker spot, even like up here at Washington Road or someplace like that, you'll be able to pick it out of the sky. It is a pretty clear triangle below Andromeda there, and find it that way too. Okay, next one. This one's pretty cool. The Leo Galaxy triplet. You can, with the right field of view, see three galaxies in the same field of view. You've got the two Messier objects, which are a bit brighter, and you've also got NGC 3628, also known as the Hamburger Galaxy. And you can guess which one is the Hamburger Galaxy in the picture. Actually, the Hamburger Galaxy also has a faint tidal tail. You can, if you look closely at Greg's picture, I saw it on my screen, you can start to see the tidal tail going downward below it. But there is a faint trail of scars that have been, dragged out by an interaction with another galaxy in the past. These do have low surface brightness, especially that Hamburger Galaxy. So you really need a telescope to make out much detail. You can see the two Messier objects in binoculars, but they're really just going to be smudges. Anyway, I think it's pretty cool to be able to see these three together in one field of view. All right, next slide. How do you find these? You can pretty clearly see Leo there. So look below, look to the southeast of that star Curtan in Leo, and you'll be able to find that one. All right, next one. All right, we've talked about open clusters, we talked about a double star, you talked about galaxies. Now we're going to finish up with nebula. I mentioned that the easiest, brightest, a nebula you can see with your naked eye, and you really can if you go out on a dark night and look up at Orion and look at the belt, you can make out the Great Orion Nebula, and with binoculars you will have no problem seeing the Great Orion Nebula. It's pretty cool that you can see this with just your eyes. It is an emission reflection nebula, so you're seeing light going in gas, but you're also seeing light reflected from other stars as well. And this is the nearest stellar nursery to Earth. So there's actually stars being formed within that gas cloud. And you can see, relatively speaking, we were talking about, remember how many million light years away from Earth the Andromeda Galaxy was? Well, you know, the Great Orion Nebula is within our own galaxy, so it's only 1,300 light years from Earth. Another thing that could be useful for this, we haven't talked too much, I know, I think I've mentioned it in some of my presentations about observing, but filters can help with observing some of these objects as well. A filter will do literally just that. It will filter out some of the light that is not necessarily a part of the object you're looking at, and emphasize the object that you're looking at better. So UHC, which stands for ultra high contrast, or an oxygen 3 filter can be useful on this object. Overall, if you're using a filter, the field of view will look dimmer, but there'll be greater contrast for the object that you're taking a look at with the filter, if you've got the right filter that you're using there. I'm not going to go into the history of this. Yeah, again, something that visible goes way back in terms of people observing it and recording about it as well. So going to the next slide. So how to find it. And, you know, Alan found it in Dave's picture before. It's really right there in the Sword of Orion. So just look for Orion Sword and you will be there. It's that fuzzy quote unquote star that's in the middle. All right, next to last one is the Crab Nebula. This one is super cool. I know I'm saying that about a lot of these here, but this one really is. It's the remnant of a supernova explosion that was observed by pretty much everybody, you know, back in 1054. What's really cool is that it had a peak magnitude of -7, which is really bright. It was so bright that you could see this supernova during the day. That's how bright it was. Today it still rates as one of the brightest natural stellar events ever recorded. It's pretty famous in all sorts of cultures because of that.
How often are supernovas, you know, visible at night over the years? How many have we seen? Just roughly, I mean.
I don't have a good number for that.
Years, do you have any idea?
I wouldn't say it's very often. I know, like, when there was a supernova visible last year, I think there was a nova and a supernova. The supernova was in another galaxy, so that was not within our galaxy. You definitely needed a telescope to look at that. The nova, I know, was a telescoping object as well. Does anybody else have an idea of how often, maybe even just based on people who have been observing much longer than I am, how often do you see supernovas coming up?
I think there was one in 1987 in the southern hemisphere. It was in close. And that's the one where the neutrons showed up before the light did.
Oh, cool.
And those are one of the Magellanic Clouds.
Is that what it was?
Those are one I'm still watching, yeah.
Yeah, still watching it. It's quite spectacular.
So it's like on the order of decades, it sounds like.
I've heard something like naked eyes once every 100 years or so.
Yeah, well, for naked eye, for sure, yeah. Or I should say, naked eye during the day is one and only, pretty much, yeah.
Except that Betelgeuse would shoot off any day now.
Any day, or any century, or any millennium.
It's way closer to the track.
Yeah, that is one they're monitoring as well, that's true. All right.
It says about every 50 years one goes off in our galaxy.
Okay, thanks, Bob.
Not that it's visible.
That might not be visible exactly. The galaxy's big, but you know, some fraction of that will be visible to us.
Thank you.
Just a note too, that's another one that can be good with filters to help bring out detail too. So where to find this? This one's not too hard to find either. So Taurus there, look off on the, I'd say they call it the left side horn there of Taurus. All right, and with that, we're going to move on to our last couple objects, which are near each other. The Rosette Nebula, also associated with the open cluster that's shown here. This is a hydrogen-2 region with stars formed from the nebulous matter. So that's why those are associated. Remember, a nebula can be a stellar nursery, and that open cluster, remember, those are stars that are formed in the same stellar nursery. So you're seeing both of those here together. This is another one that is really, you're going to need some magnification to see things. You can see the cluster with binoculars, but you're going to need a telescope to see the nebula, and filters are going to help you here as well. Next slide. So where to look at that? So remember, I talked about you can look at the winter polygon. If you narrow it down to a triangle, the winter triangle, look for it between Betelgeuse and Procyon there. And you can use Orion there as a guide too. Okay, next one, the Flame Nebula. This is an emission nebula, so this is actually glowing. It's not just reflecting light from other objects. It's part of the Orion Molecular Cloud Complex. Can't say that very well. Which is, a bunch of glowing gas and other star-forming regions. If you look around, if you just start panning around a region, you will see a lot of nebulosity and things in there. Again, telescopes needed for this, and filters will help as well. But these are very interesting objects to look at if you get those filters. And with Greg here, you can see they're great photographic targets as well. You find that in Orion. So just look southeast of Alnitak. So that, if you're looking at like the left star in Orion's waist, that's Alnitak. And just look southeast of there. It's a pretty easy transit down to it. And finally, we're going to get to the last object in my presentation. Remember, I talked about the iconically challenging object. This is one that a lot of people really want to see, including me. It is a challenge. It is difficult to see. The Horsehead is a dark nebula. That's what the B33 is, and the IC 434 is that emission nebula that's around it, that it's really standing in contrast to. You need dark skies for this. If you use a hydrogen beta filter, this can help make the bright nebula behind it stand out, and hopefully make the Horsehead more distinct. I have tried to observe it up at Washington Road. I tried it last month to go see it. Yeah, the Horsehead. Do you see the Horsehead? Yeah, this is the Horsehead right here. There's his nose. I have gotten to the point where I can, if I'm using averted vision, I can sense the dark area there, but I've been nowhere close to visually seeing the shape of the horse's head there. So it's a definitely challenging object. I want to try it from a darker spot. I mean, up at Washington Road, we're typically, Bortle 4. On a really good night, you might get into Bortle 3 range. I'd really like to. One of these nights, I'm going to have to, in the summer or late summer, stay up late or get up early in the morning to go out and try to see Orion.
What size scope do you have this for?
I have an 18-inch scope, but I think the challenge is really I need to get darker skies to get more contrast with things. So
Alnitak is really bright also.
that's a very good point. You need to sort of move it out of the way, move it out of your field of view. All right, and lastly here, where to see it? Well, keep going down from Alnitak past the Flame Nebula, and you're going to get to the Horsehead Nebula there too.
Is that dust?
Is what dust?
The Horsehead Nebula?
Yeah, it's basically dust that's blocking the light from the glowing nebula behind it, from the bright nebula behind it.
Do hydrogen clouds block light, or are they transparent?
No, they wouldn't be blocking light, they would be glowing light or reflecting light. Yeah, so it's not blocking the light. Okay, last slide. That's my presentation. Please take this as an incentive to go out there. It's really not that cold. Even if you just step out in the evening with the binoculars, you're going to appreciate, like, what was it, just a couple nights ago, the moon and Jupiter were there together. It was a nice conjunction up there, just looking out in the evening sky. You didn't even have to use your binoculars or anything. They were right there. So go out and take a look. If you have any questions about observing, if you want to come out and observe sometime, if you've got questions about a telescope, feel free to contact me. And I'm happy to take any more questions.
Ron?
Yes?
One of the things that I've experienced over a number of years of observing is the disappointment among new or would-be amateur astronomers is that what they see through the eyepiece doesn't look
That's a
anything
good
like
point.
these
That's
photographs.
a good point, Marv. And thank you for bringing it up, because I meant to mention that at the beginning of my presentation. I completely forgot to do that. So the pictures that you see here are that. They are pictures. You're not going to see these things when you look through your telescope. You're going to see light and shades of light, with the exception of, with the exception of like some of those colored stars and stuff. So don't expect to see what you're seeing here. Put them up there so you know what these things are in real life and with some astrophotography. But the challenge isn't to go, try to see, great, amazing things. For me, the brilliance is just seeing these things, period, and being able though to see, some detail. And I don't know, I find there's definitely some specialness with being able to go out and have those actual photons hit my eyeballs as well. And there's also a lot of beauty in these things just as they are. If you go out and look at the nebula, even if it's white, you do see details and you can see wisps. If you're looking at, the triangulum galaxy, you will, if you start to use a telescope, you will start to see some of those spiral arms up there too. And there's a lot of things to really appreciate there as well. So, good point. Thank you for bringing that up. Other questions or comments? All right. Oh, Bill.
You wanted to mention big star parties.
Oh, big
Western
star
states.
parties. Thanks for bringing that up, Bill. So I'm actually planning to do, I don't know if I'm going to get to it this spring, but I am planning to do a presentation at some point about star parties. But Bill's bringing up that there have been announcements made about star parties coming up. There is a star party out at Black Butte Lake in April that Bill and I have gone to in the past. Lonnie's gone to it as well. Other folks are interested in that. It's a great one. It's only just over a couple hours from here, west of Chico, and I forget what the name of that small town is next to it. Anyway, not too far away. And probably the biggest and best star party in California is the Golden State Star Party. The dates for that have been announced in July, and you can reserve your spot there now. That is way up north in Lassen County, but it's a beautiful dark site. It's on a ranch that has been opened up by this rancher to the astronomy community for years. And it's a dark site, and there's just lots of observers out there, lots of telescopes. There's lectures on different things. Last year, there was a presentation by a guy, and I was trying to get him to speak to our club, but unfortunately, due to some family concerns, he couldn't do it. He gave a whole presentation about the Hubble telescope and, all the errors that happened with that and how they happened, the mistakes that were made by different companies and all these organizational issues and stuff. It was pretty fascinating. It wasn't just like the technical side, but it was like the organizational side of things too, which is pretty cool. Probably one of the greatest current amateur observer Steve Gottlieb, who lives in the Bay Area. He talked about some different star catalogs, not going beyond the Messier and the NGC. Steve Gottlieb has actually observed every object in the NGC catalog. Yeah, and he has detailed records of each one. People ask him things, and he will bring it up and say, "Oh yeah, I observed that in 1976, blah blah blah, and in 1983 I recorded blah blah blah." Anyway, he's a very detailed guy, pretty amazing observer. But anyway, it's just a great place to go with any size of telescope. I went out there first with just my Celestron and stuff, and people are out there with all sorts of things, and you can walk around and see other things too. So those are a couple of ones that are coming up. I'm actually planning to go to Texas this year to the Texas Star Party. It's a week long. I think it's the biggest one in the country now. Have to check that out at some point. Hopefully Paul will be there too. I don't think Paul's on the line this time, but anyway, if you're interested and want to learn more, definitely feel free to check out with me or talk to Bill too. Thanks, Bill. Anything else? All right.
All right.
Thank you.
Thank you.